Hello, my name is Kelly. I'm going to be reviewing the C++ banking simulation program I wrote during my time at SNHU, followed by a plan to convert it to Python. I'll go over the code structure, areas for improvement, and explain how the functionality will translate effectively into Python. This program uses a bank class to manage investment calculations, as seen right here, allowing the users to see their investment growth with and without monthly deposits. The bank class has a private member variables to store the initial investment, monthly deposit, annual interest, years, and total amount here. The methods get input gathers user inputs for the initial investment, monthly deposit, annual interest, and years. This is a pretty straightforward way to collect and initialize values in the program. Here, display without monthly deposit calculates and displays the investment growth over years without additional monthly deposits. And here, display with monthly deposits calculates similar to the previous method, but it calculates interest monthly with additional deposits, reflecting a more realistic scenario. For the formatting, the code uses fixed and set precision 2 to format output, ensuring monetary values display to 2 decimal places. This is great for readability in financial applications. Areas for improvement. Throughout the program, I did not use comments with the exception of the variables here, and that does not align with coding best practices. So in my enhancement plan, I will be addressing that and adding in comments to each section of code that will essentially explain what that block of code is for. The naming conventions, the current variables like I inventory and M deposit, could be made more descriptive in order to enhance readability. The code repetition for the structure of display without monthly deposits and display with monthly deposits has some overlapping logic, which could be refactored into reusable functions. The user input validation currently assumes valid input. Adding checks could improve robustness. The plan to convert to Python. Python's simpler syntax and powerful libraries allow us to make programs even more user-friendly and maintainable. I'll retain the bank class, but use more descriptive variables like initial investment and monthly deposit. Python's dynamic typing will simplify variable declarations, removing the need for explicit types like float. I'll also add in input validation using try-except blocks, so if a user enters invalid data, the program can respond appropriately. Get input will become get user input, where we use Python's input function and float conversions. Display without monthly deposit and display with monthly deposit will be converted into Python methods using format strings for output instead of fixed and set precision 2. In display with monthly deposits, the inner loop calculating monthly interest will become a nested loop in Python. However, I'll refactor parts of this logic into smaller helper methods if possible, making it more modular. I'll implement if name equals main as Python's main entry point, replacing main with the parentheses in C++. This will create an instance of bank, gather input, and call display methods in sequence. By translating the C++ code into Python, I'll improve the code's readability, modularity, and user experience using descriptive variables, input validation, correct commenting to explain code blocks, and Python's simpler syntax will create a more user-friendly version of this investment calculator. This portion of the code review is for the database section in my capstone at SNHU. I will provide a detailed code review of the library management system I created in Java, highlighting strengths, identifying areas for improvement, and discussing plans for future enhancements. This review will cover the existing code and the proposed enhancements I intend to implement as a database-backed storage layer and secured logging for improved scalability, data permanence, and system observability. In the code review, I will go through each page. There are 4 files. My first page, my contact page here, this class represents a contact object with attributes such as contact ID, first name, last name, phone number, and address. It also includes validation methods, as seen here, to ensure the integrity of the data input. The strengths of this file are the validation methods effectively prevent invalid data such as incorrect name links or improperly formatted phone numbers. The class is well structured with clear getters and setters and logical validation. The areas for improvement, error messages for validation failures could be more descriptive to aid in debugging, considering abstracting the validation logic into a utility class for reusability if similar validation needs arise elsewhere or in the future. For the contact service, as seen here, the overview of it, it manages contact objects currently using a hash map for storage, which is effective for in-memory operations but lacks data permanence. It also contains methods to add, delete, and retrieve contacts. The strengths of this, the hash map implementation provides efficient O1 time complexity for basic operations. The code is easy to read and understand with well-defined methods. The areas for improvement, the use of an in-memory hash map kind of limits the scalability and data persistence. There's no built-in mechanism to log or handle errors comprehensively, making it harder to monitor the system's health and behavior. The contact service test, as seen here, unit tests that validate the behavior of the contact service, ensuring that adding, deleting, and updating contacts work as expected. The strengths for this file, it's well-organized test case that cover basic functionality effectively. There's good use of assertions to verify expected outcomes. The areas of improvement could be more comprehensive tests to add to cover edge cases, such as trying to update or delete non-existent contacts. Once the database is integrated, tests will need to account for database operations and potential issues or potential connection issues. For contact test, the unit tests for the contact class focusing on validation logic. The strengths for this, thorough testing of input validation, ensuring that all data constraints are enforced. Use of assertions.assert throws to test that invalid input triggers appropriate exceptions. Where it could be improved, group tests and add comments to improve readability and maintainability. I don't think I did very well on the comments to begin with, so I will be improving that. Edge cases, such as boundary values for name links, could be added to improve robustness. And the enhancement plans that I have, the contact service class will be upgraded to connect to a MySQL database, replacing the hash map with a permanent and scalable data storage solution. Additionally, structured logging will be added to track important operations and errors systematically. The database integrations, a connection object is established to interact with a MySQL database. SQL queries are used for adding, updating, deleting, and retrieving contacts, ensuring data persistence and enabling complex queries. For logging, Java's logger is introduced to log essential events such as successful operations, warnings when contacts aren't found, and severe errors. This logging provides visibility into the system's behavior and aids in troubleshooting and performance monitoring. The benefits of the planned enhancements that I have are scalability. The data-backed storage will support large data sets and concurrent users. Data permanence, The contacts will persist between sessions, ensuring long-term data availability. Observability, structured logging will give me insight into the system's operations and make debugging easier. Hopefully, this is a solid foundation to work towards the enhancements that I want to implement. By integrating a database and adding structured logging, I'll make the system more reliable, scalable, and easier to monitor. And I'll prioritize the updates and hope for a smooth transition into the new architecture. This section of the code review is for the algorithms portion of my capstone at SNHU. What is before you is a program I wrote in C++ and OpenGL. The application creates a window using GLFW, initializes shaders, renders a shape using glue and GLM libraries. It has several strengths and areas of improvement that are needed, and at the end of the description or the code review, I'll go over the enhancements that I plan to implement. This code uses modular structure with clearly defined functions for initialization, rendering, and shader management. Separation of responsibilities make it easier to maintain and extend. The code demonstrates a good understanding of OpenGL concepts using vertex and fragment shaders efficiently. Mesh creation and data management are handled pretty well with VAO and VBO integration. The areas for improvement are graph handling. Currently, the code does not handle graph data structures required for the specific algorithm that I want to implement. There's no support for nodes, edges, or weighted paths, which are crucial for graph-based algorithms. The application is focused solely on rendering with no back-end logic for executing pathfinding algorithms or visualizing graphs. Users cannot interactively input or modify graph structures, which would be necessary for the algorithm I'm planning to implement. To make this an OpenGL application capable of visualizing and using Distra's algorithm, I need to enhance several aspects of the code. I'll need to introduce a data structure to represent graphs, including nodes and weighted edges. To do that, I'll create a graph class with methods to add nodes, add edges, and store weights. Use adjacency lists to represent the graph efficiently. The implementation of the algorithm for finding the shortest path in the graph, I'll have to use a priority queue for efficient minimum distance retrieval. Maintain a predecessor array for path reconstruction. To input flexibility and user interaction, I'll have to allow users to input graph nodes and edges interactively, either through the keyboard input or through a GUI, a graphical user interface. The plan to do that is to use keyboard commands to add nodes and edges dynamically during runtime, and to implement a simple GUI using IMGUI or something similar to make graph input easier. For the enhancement details, I'll capture keyboard input using the uProcess input function to let users add nodes or edges. Display graph information using text overlays or simple shapes to visualize nodes and edges. For the graph visualization, my objective is to extend the rendering loop to display the graph structure and highlight the shortest path found by the algorithm. And my plan to introduce that is to use OpenGL to draw lines between nodes for edges and different colors to represent the paths. I need to update the render function to render the graph dynamically based on the graph's data structure. I'll need to define vertex positions for nodes and use simple lines for edges, and highlight the shortest path using various colors, updating in real time as the application runs. For performance considerations, I'll need to optimize the graph rendering and algorithm performance. The plan for that is to ensure graph visualization is efficient by minimizing redundant OpenGL calls. and to use efficient data structures for graph operations to handle large graphs smoothly. To summarize the enhancements that I plan to add in, and I'm hoping will work in the end, to add a graph data structure using adjacency lists to store nodes and edges efficiently, to implement Distra's algorithm and a priority queue for better performance and a predecessor array for path reconstruction, interactive graph input using a keyboard and GUI support to let users add and modify graphs, dynamic graph visualization, and rendering the graph using OpenGL with paths highlighted in real time. Those are the enhancements that I'm planning to use. I'm open to any suggestions or any feedback regarding any of the enhancements that I have pointed out in this presentation. I am totally open to it. Thank you so much for listening, and I appreciate it.